And so to understand sole tenancy, it'd be of importance for you to understand how virtual machines are allocated or how resources are allocated to your virtual machines on creation. So there's an interesting link that actually shows how sole tenancy works. And so typically what you'd have is Google uses what's known as a scheduler. And a scheduler's job is to identify, hey, what parts of our data center, what as a whole, are not receiving as much utilization. And what we want to do is take, let's say you've started a new virtual machine. We're going to take that VM and fit it within our malleable or configurable data center in a place that it could be running near different projects. So you may have a project that's running next to a massive company's project, but there's a level of isolation behind that. So to understand sole tenancy, you will need to understand the idea of job scheduling. When you ask Google for some resources, let's say you want a new virtual machine, remember that there's so many different projects and so many different users who are using resources in a data center. Google needs to find an efficient way of bunching up your different sized workloads in a way that it will fit and minimize the amount of wasted space. So as shown in this diagram, you may have a resource, let's say in VM1 shown in green, that's running near a different project for a different company that's running near a different project. And notice that they're all of different sizes. So it's similar to the knapsack problem in computer science. What's the best way for you to arrange a particular set of configurations given a particular set of specifications? So you can have VMs that have different resources, some are larger, some are smaller. How can I squeeze them all in within this tight confined space such that I am effectively maximizing utility from our customers? And so that's part of a multi-tenant architecture that you're actually seeing here, where you have different customers running within a single node if a node is represented by this large square. However, when you're talking about sole tenancy, you now have, Google now says, okay, cool, you've asked for a very special kind of scheduling where I get to schedule all the resources that you want in an enclosed environment. So you almost get full control over, let's say, a block of, you get full control of an entire host. So an entire server rack. So you can just imagine a server rack that becomes yours. This almost never happens in any data center by default. But in this case, sole tenancy allows you to take full ownership over an entire server rack. So now not only do you have ownership over your virtual machines and assurance that they're all running in the same place, you have full control over the hypervisor and the hardware. So if you're running extremely secure workloads, you have the ability to now, with full confidence, say that, hey, I know for a fact that no security vulnerability that, say, leaks information through the hypervisor can exist because everything of mine is physically contained in one unit. Another reason you may opt for sole tenancy is through the use of regulations that's actually documented within this documentation. So other than just simple utilization and security, you may be regulated by whatever company or board or even government to be able to isolate certain information on a hardware level from different other resources or other vulnerability points. So through the use of compliance and regulation, there may be cases where you must have your data isolated physically from other vulnerability points or other areas and facilitate that form of physical separation. So currently, the only way for you to be able to use a sole tenant node is if you rent out the 96 core 624 gig RAM unit. So that will encompass a whole hardware unit in which all your virtual machines that you schedule can run there. So after creating that sole tenant node, you can now use, for instance, things like node templates and run smaller virtual machines within that entire sole tenant node.